This video is on solving systems of equations by graphing. We're going to use the slope-intercept method, but you can use any method you know to graphing lines. Example 1. You have the function y equals negative 2x and the function y equals x minus 3. If you do not remember how to graph in slope-intercept form or any other form, please look at other videos. You can use whatever form you want to graph these. I'm just going to use slope-intercept because I think it's the easiest. I'm going to label my m, which is negative 2 for the first one. And because it's a whole number, I'm going to put it over 1 because it's easier to use a fraction. My b for the first equation is 0. So I'm going to start at 0, and I'm going to go down 2 to the right 1. Down 2 to the right 1, down 2 to the right 1. And I'm going to draw my line. It is important that you use a straight edge and that you use graph paper so that these come out accurately. Now I'm going to do my second one. I have a slope of 1 because there's an x there, but there's no number there. And we're going to put it over 1. And b is negative 3. So I'm going to start at negative 3. And I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. I'm going to draw my line. And that's why you want to use graph paper and a straight edge. There we go, that's a little better. Okay, so right here is my point. That point is 1, negative 2. Remember, the solution to a system of equations is where the two lines touch, or where they cross, where they intersect. So my point is 1, negative 2. In a minute, I'm going to show you how to check this so that you know whether or not you got this answer right. This is important, and it's a great way to make sure that you get 100% on a test. To check, you first need to label your coordinates, x, y. And then you're going to substitute everything you know into each equation. So my first one is y equals negative 2x. Well, I know y is negative 2 equals negative 2 times x of negative 1. So negative 2 times 1 is negative 2 equals negative 2. So the first one checks out. Now let's check the second one. I have y, which is negative 2, equals 1 minus 3. 1 minus 3 is negative 2. So I get negative 2 equals negative 2. So that one checks out. So that is the solution to this system. Sometimes you will have what are called special cases. In a minute, lines are going to appear showing the two types of special cases. The first one is no solution. If you look at the two lines, they are exactly parallel, meaning they have the same slope. These lines will never, ever cross. So if they have the same slope, they're parallel, and they never cross, meaning it is no solution. For the example of infinitely many solutions, I'm going to draw the line separately. So I drew the first line, y equals x plus 2. Now I'm going to do the second one in blue. Well, if I solve this for y, that means I need to divide each piece by 2. That means I get y equals x plus 2. What do you notice about these two equations? Well, I start at 2 and I go up 1 over 1, up 1 over 1, up 1 over 1. This is looking really familiar. Well, it is the same exact line. That means any coordinate pair on that line, even decimals, will work for both of those equations. That means the answer is infinitely many solutions. Another vocabulary word is coinciding. Coinciding means same, or that the lines are on top of each other. Both parallel and coinciding are words you're going to need for geometry. There are no real ways to check these other than to throw a couple solutions in. But if you come up with no solution or infinitely many solutions, most likely, if you graphed them, they came up like this, they're correct. Now it's your turn to give some a try. Please try 2 out of the 3 problems. Number 1 is y equals 3x plus 2, and y equals negative 3x plus 2. Number 2 is y equals negative x plus 3, and y equals x minus 4. Number 3 is y equals negative 2x plus 4, and y equals negative 2x minus 3. Good luck!